malfunction training, and also we are talking about procedure training, how to start the aircraft, how to start the APU and all that. Okay. The second one is, I can say, quite a low level flight simulator as well. What we call is FTD. FTD is something we call a flight training device. It's kalau if you compare to the one on the right, it doesn't have motion. So again, just like the IPT, it give you FTD give you a better feeling in terms of handling, aircraft handling. You can feel the control loading, how the uh, yoke react to the system. So it give, and then if you go inside the cockpit, it's more like a real life aircraft basically. On the right side is a what we call a full flight simulator, FFS in short. So the full flight simulator is more towards like, I can say, 99.5% exactly like as per aircraft in terms of feel, in terms of performance, in terms of what do you call that, the cockpit layout. It has to be as exactly as the aircraft it represents. All right, so it can be Boeing 737 Max, Boeing what do you call that, NG. It can be 777. It can be Airbus A320, A330. So but there's the regulation whereby, which I will explain later on the regulation a little bit, on how we manufacture the flight simulator. Okay. Okay. This is a little bit of flight simulator general overview. So in this picture, it was taken back in 2000 and October 2019 when I first joined Ryanair. So we installed one of the machine. This is a 737 Max, Max, and so if so this is I call it usually kalau you tengok, if you look at cartoon to How to Train a Dragon, this I call it How to Train the Simulator, because the thing is I'm I have been assigned to this particular exact simulator, so I'm becoming the master to the simulator. So it's a what you see here, you won't see it. You won't see on a daily operation. It's only during installation because we disable all the safeties just to check the envelope and everything. So if you can see there, it's a big, quite a huge simulator compared to myself, and you can see there's a 6 jacks down there. What give the feel of the motion movement. Okay, in total we are looking at 6 degree of freedom. It should be giving you the exact precise movement of an aircraft when on air or on ground. All right. So I'm not going to go into deep into the technical side of it or the system, because it's going to take hours. Because for us, when we explain about flight simulator system, it's going to take about 3 or 4 hours easily. Okay. Okay. Now this picture also about the same towards the end of 2019, where I'm doing my testing on a 737 Max. Okay. If you look at if you look at the aircraft inside the cockpit, it replicates exactly how it should feel, the measurement, the feel, the tactile feel, it should be exactly the same. Even the color of the PFD, if you look in front of me, there's the artificial horizon on the PFD. Even the color should match exactly the aircraft. Okay, what makes this the Max easier is because most of the component that you see there, all the instruments, are aircraft instruments. So it will represent you the exact representation of the aircraft. So if just to give you an oversight, how much it costs to not to build but to buy a flight simulator. This simulator that I'm flying, it costs about 22 million USD each, right? And every instrument that you see there is going to cost you about easily about 50 to 60,000 USD each. All right. Okay. This simulator is a mixture of simulated instrument and also aircraft instrument. Some simulator do have, like, in order to save the cost of the flight simulator, they build it as a fully what do you call it? simulated instrument, but the feel and the look is not as good as the real aircraft instruments. Like, okay, so this testing was because this is my what this was the first testing with Ryanair when they first installed the machine. Because as a flight simulator engineer, I'm responsible to get everything running. Making sure that all instruments, all performance are at par. So yes, usually it takes you about 10 to 15 years to get used to the system, to understand the system. It takes time a little bit, but yeah, here I am where the in term of performance uh, is quite accurate. Yeah. Okay, let's go into the a little bit of the regulatory. Okay, okay. There's two documents that uh, simulation industry refers to. Okay, one is the PRD, which is a primary reference document. So what is a PRD basically? So it's a document against which the competent authority qualify the FSTD for training. So basically we have a couple of well-known authority worldwide. Most of them are like, we have, every country has their own authority. Like for example, Malaysia, we have CAA Malaysia, but most of the country will refer to two major documentation. One is from EASA and or one is from FAA. Okay, but most Asian country and most Europe country will be referring to what we call it CSFSTDA. So CSFSTDA refers to certification specification flight simulation training devices. So A at the end to it signifies aircraft or a plane, or what we call it a fixed plane. If it's CSFSTDH, it's going to be like it's going to be for helicopter. So now EASA is working with on another document to cater the PRD for the helicopter, because no, sorry, for the VTOL. Because the problem is VTOL is a combination of aircraft and helicopter. So they need to come up with a new regulation on how to evaluate the VTOL in terms of aircraft itself and also the flight simulator. Okay. So basically, this CSFCTDA now it comes with issue two. The initial issue was released back in 2006. 2006. Now we have issue two. So any flight simulator that being developed, that been installed after starting from June 2018 onwards, they will be referring to this new issue two. But whatever we have, the older version of simulators before June 2018, we still they are still using initial issue, which comes under the regulatory grandfather's right. Okay, so a bit more on the PRD. So the purpose of the PRD is document defining the mandatory requirements for qualification and compliance of flight simulator training device, whether it's for initial evaluation and recurrent evaluations. So the document will define the qualification level of the flight simulator. So we have level A, B, C, and D. But worldwide, mostly we have C or D. Even though in Ryanair we do have level B before, but every level we have its own limitation. Okay, so for level D is the highest certification that we can have on a flight simulator. So when it comes to the highest level, also is known for zero flight training, ZFT. So when zero flight training, meaning that the authority agrees that level D simulator qualifies as a real aircraft basically. So if you look at a pilot flying schedule, So between they must have is it minimum of 8 hours rest between the last flight to the next flight. Minimum 8 hours rest. But for level D simulator, it reacts the same way. So let's say your what you call it, your training stops at 12 midnight, right? So you need minimum of 8 hours rest before you can go for a real flight. So the authority, uh, dia they act they classify the simulator as a real aircraft basically because of the performance, because of the representation of the aircraft. For level C, it's a little bit a downgraded version of it. You need minimum about, I can't remember, is it 12 hours or 24 hours before you can go for a real flight. And then certain training like night training can be done on level C. Okay. Okay, so basically the PRD will table a validation tests. What tests need to be done on the flight simulator in order for it to be qualified as B, C, or D. Okay, and also it gives you a MQTG format and presentation. So what is MQTG? I will explain to you in next couple of slides. All right.
Shah,
Yep.
what's the highest standard? Is it D? D
D
is
is the highest standard.
the highest
D is
standard.
the highest standard. Yeah. So also, like I said earlier, it's also classified as a real aircraft,
Mhm.
uh, and then it's also classified as a zero flight training punya device,
Usually, how long
which
is the
means
training for flight? How many hours you
so
fly?
minimum is 4 hours, right? 4 hours. It doesn't include 1 hour briefing before and debriefing after the training. So in total about 6 to 7 hours. But for Ryanair, it depends on the airline. Minimum is 4 hours. But for Ryanair, for example, they do 5 hours in the cockpit.
With
All right.
short haul flight tu, yang 1 hour flight tu pun dia akan simulate 4 jam juga ke atau?
Yes,
Oh, I
yes,
see.
yes. So, but the thing is, you have to remember when they go inside inside simulator, it's not like they're doing a full. Maybe for the initial training, they go like for example, KL ke Penang kan, they
Hmm.
they'll they'll do the full flight. But for recurrent pilot who comes in for recurrent, just to revalidate their license, right? So they don't have to go through all those initial training anymore. So
I see.
they just go through all the malfunction training. What do they do when they have a engine flame out, for example, and if there's, let's say, decompression at 30,000 feet, what are the procedures they have to follow?
I
Okay,
see.
so they cut short everything. So okay, one good thing when you train on a flight simulator ni, you can freeze the simulator. Say, let's say, oh, I need to go to the toilet, you can freeze simulator, lower down the motion, they can go to the toilet and come back, or they can go for a break. All right. So something that you can't do on a real aircraft. That's why when it comes to flight simulator, it's more cost effective to the industry, right? Yeah. So now with the new generation of flight simulator, it replicates the aircraft to almost, like I said, 99.5% in terms of fields and representation. So it gives the authority the confidence saying that uh, this is next to the aircraft. So all these document will be the guideline for the manufacturer like CAE, and also for the flight simulator maintenance engineer like myself, a guidance how good the performance of the flight simulator is. Okay, Prof?
All right. Okay.
All right. Okay. So there's another document which is very, very important, which is aircraft manufacturer reference data. So basically, I just give you this. The one that I show you on the screen now is the real life data, meaning that is the current one for 77800 winglets. I can't show you the whole thing because it's proprietary. I do have the whole document, but it's not meant to be public presentation. So what Okay, both. Okay, the PRD earlier, the CSFSTDA will is used by the authority. YASA developed the document to tell the manufacturer what need to be tested on the flight simulator. There's about between 150 to 200 cases that you need to test that you need to perform on the flight simulator, objectively and subjectively, right? So they only tell you how to build the flight simulator, the reference, and what need to be tested. Okay, but another validation data is what's needed is what is the test result is against to. Okay, so for in this case, like for example, the document D611A049 Ref B, which was released in February 7, 2006, it gives you a comprehensive flight data of 737-800 with winglet. Okay, this does not apply with to any other aircraft, and also does not apply to 737-800 without winglet. It's only for 800 with winglets. Okay, so it gives you all the data that need to be computed in the flight simulator and what need to be tested. So there's a group of big group of engineers, for example in CE Montreal, who do all this programming. They program the simulator based on this integrated validation data. So they use this as their reference. So how the aircraft should perform. So when on, for example, on normal takeoff, right? So there's a like they need to look at the calibrated airspeed. They need to look at the flaps. So this all of this data are being programmed or being the coding is being written in the flight simulator that compile the whole simulator. So this is a subscription by Boeing basically. So every airline, or not airline, sorry, the every aircraft flight simulator manufacturer will have this in their hand as a reference. So they can't deviate from this document. So all, the authority will also see. This is what something like a low level flight simulator that, remember we were talking about the one in what do you call it, in UPNM. They don't have this data. This comes under something we call it data package. They won't have this one. So they don't have a way to validate the software inside the system, because this document itself or the data package. For example, I give you example for Airbus A320, the simulated data package provided by Airbus gonna cost you about 3.2 million USD to get the data from what you call that, from manufacturer, from Airbus itself. So that what makes flight simulator so expensive. It's not about the hardware. The hardware is cheap, but the software that which is super expensive basically. Okay, now, so this is what it looks like. So I'm going to explain you about what QTG, what we are testing inside the flight simulator, right? So now, in order for the manufacturer and in order for the authority to know how good is your the performance of your flight simulator, we use as QTG as a basis. Okay, a QTG stands for Qualification Test Guide. Okay, so basically the test show how closely the simulator behave compared to the real aircraft objectively. So the thing is, there's two way of testing simulators. One is objectively, like I said earlier, and also subjectively, right? Usually in the as an authority, they will look at the objective first, which is the QTG. If the because if the objective testing does not pass, forget about the subjective. They won't bother about subjective. They know that it's going to fail. The aircraft going to fail, right? So what is against two? So the simulator data, if you look on the right side, you have two type, blue reference data, and also the green dotted line is a CE simulator data. All right. So the blue reference data is the aircraft data, right? And then the green one is a CE simulator data. So it should overlap, right? But if you can see on the first graph on top, the first plot, the calibrated airspeed, the first I think it's about the first 6 seconds is out of tolerance, right? Because uh, what makes it out of tolerance is aircraft data said the speed the speed should start at 30 knots, but instead the simulator data starts at 0, which is wrong. So what happened here usually, uh, will feedback to the manufacturer. The engineer will tune it back, will reprogram, recalculate the program so that it starts from 30 in order to match the aircraft data, right? So like I said earlier, we are running about 150 to 200 tests depending on aircraft being simulated. But for commercial like Airbus and also Boeing, it's about 145 cases in total. Okay, the QTG will test all the flying maneuvers, flight controls, motion, visual, sound, and all that. And then all the QTGs need to be rerun every year on every sim. So this is what we are going to to present to the authority on yearly basis, because the certification has to be renewed on yearly basis. So the authority will comes to the training center. First, they will sit down and look at all the QTGs. All right, look at this. So if they're happy with it, then they start the second phase of subjective testing. Usually, it never happened on me, but I heard if there's a story whereby in one of the training center, one is in the world, the QTG presentation was so bad, there's so many failing. The authority just walk out the training center, said, "We are not going to qualify this one. You get things fixed first, then we come back and we qualify your simulator." Right? So the rerun has to be done on every year. So it shows that your how it performed. Does it degrade from the initial, from the MQTG? So they want to see if it degraded. They want to know why. Is there any software changes? Is there any hardware changes that causing all this? Right. So we have to justify to the authority what happened, and then if say there's a changes, and is it better or is it slightly worse from the master initial document, it has to be remastered basically. So because the master is the birth document that it shouldn't change, but on certain circumstances it can be remastered based on upgrade performance. Like for example, last year, I did the visual system. I upgraded the visual system on one of our flight simulator in Ryanair from an old version of visual system into a newer version, because the older version is obsolete. So we did an update. So what happened was the whole QTG package for the visual part need to be changed. So there we had an what do you call that, special evaluation by UKCAA and also EASA authority to ensure that all the upgrade has been done properly and the QTGs are being run satisfactorily. Okay. Okay. I did mention about the master question test guide. So basically, again, the QTG is a series of tests that prove the same behavior like the real aircraft. Right? So like I said, like I said earlier, the MQTG will only be created when the simulator first stop. What we call as an initial evaluation. So we use is being used as a comparison on yearly evaluation. Like it shouldn't, the aircraft performance shouldn't be great from what it was certified before. But like I said, if it's degrade or if it's improving, so it needs to be remastered. So it's an evolving document, changes and changes and improvement as the semester changes, sim updates, strategy improvement, and so on and so forth. Okay, what are the QG testing? So in terms of testing types, things that is testing aircraft performance, other flight test performance, handling performance, and also it's also testing certain systems like motion systems, visual systems, sound systems. Okay, like aircraft performance is testing the taxi, takeoff, cruise, braking, flight control, air maneuvers, and landing. Other flight tests like ground effect, inertia, and envelope protection only for Airbus. And then as well like Fugoi and all that. So, but to make it complete, we are also testing the motion system. So the motion system. So how does it feel when the pilot fly, right? When it take off, you should feel like they are in a real flight like real aircraft. That's what we want to present. So that's why the motion system is very crucial. Because in certain training may use they might need motion, they might not. But for training that requires motion, if say there's a problem with motion, so we can't engage motion for that simulator. What happens if they can get a training, it becomes UG, or it becomes like void now for that training. So they can use that particular flight simulator for that particular training. Okay. And just yourself all the geometry they put a visual in front, right? So when you have like a real airport, for example, like KLIA airport, or you have a sensor airport, for example, he has replicated every single light, every single signboard on the runway that has to be exact, right? So because we don't want to mispresent to the pilot, right? So for example, there's one time that instance the signboard it says S for Sierra, right? But the newer airport they change it to Sierra 1. So we have to upgrade the model database of that particular airport to reflect Sierra 1 because if not it will give the pilot wrong information basically. So it has to be precise. And also for example on the runway it always can be a number, right? To for example sensor is in left right now. Last time it used to be only in on the runway. So one of our simulator before was not being updated. So it shows until we had a complaint from the crew saying that it's not right. So we can't use this for training. So we have to spend about about 40,000 just to buy the new model database and install it inside the flight simulator. So this is the philosophy. The philosophy what in flight simulator testing, right? So basically something will drive the input, and also something will record the input, right? So we're looking at, for example, in this example, there's a column input. It should when there's a column input, you should have an elevator movement, right? So when there's an elevator movement, you should feel there should be a pitch changes on it, right? So basically, when it comes to driving input, in order to ensure the repeatability of the test, usually there's a script we call it CIS, being developed by the simulator engineer in Montreal. So that what me as a flight simulator engineer, we just press the button and the system will test it for me. Right? I don't have to put that because what the authority wants is you must have when it comes to running QGCT, you must have minimal, very minimal human intervention. It has to be automated. So that because the thing is when it comes to script, it doesn't change, right? Human behavior change, but computer script it won't change. So it will be the same over and over again unless someone decided to change something in the script. Okay. So when it comes to PGG, repeatability on every year basis is very crucial. Even though the simulator was installed 15 or 20 years ago, when you test it now, it should behave the same way how it was 20 years ago. Okay, these are some of the sample cases that I can show you. For example, right now it's a normal takeoff cases. Actually, this is only if you look down there, it's only page 2 of 13, 3 of 13, but I'll snapshot for you some of the important that I will see most on daily basis, right? So most of the time you have calibrated airspeed, ground speed, radio altimeter, control column position. This is how we look at it. Also, okay, before I forget, the QGG can also be used not only for the authority, not only for showing the performance of the flight simulator, it also can be used as an engineering tools. Okay, how it works. For example, let's say, for example, I have what do you call that? Calibrated speed which is out of tolerance. I have a ground speed which is wrong. It's showing red. So I can determine because it's about three or four plots in a page. You have 13. Basically, you have about 52 plots which show the performance, right? So there must be like if something if the calibrated speed is failing. There must be a reason why. It can be uh, the control column is not being driven correctly by the software, or maybe it's out. The control column is out of calibration because we have, like for example Boeing, we have a lot of mechanical parts, so it need to be calibrated at least once a year to make sure it feels the same. It doesn't the fields doesn't change. So I can use this as an engineering we call that tools to ensure that what's wrong with the system. Okay, for example, I give you example like okay, when going down the runway, when doing a normal takeoff, the crew said that it doesn't feel right, right? It feels that the rudder doesn't feel right. So okay, when it comes to feel, it's very subjective. One pilot can have a different feel from another pilot. So what I do usually, I run the QTG for rudder, for example, right? So I'll see the objective test first. If it pass, and then the next step is to get another pilot to re-evaluate the rudder, because I can say 99%, the next pilot will say that it feels all right. It feels like the aircraft, so don't do anything. That's most of the cases. So that's why when a pilot say something doesn't feel right, never don't start changing things. Don't start tuning things. Run the QTG first for the rudder and see how it looks like. But there's a case whereby the the QTG do fail. So when it fails, that's where you need to, which confirms that there's something wrong with the rudder system. So you need to investigate further whether you need to do tuning or you need to replace a part. That one will depend on your engineering judgment. But as a start, objective testing is the best way to test the health or performance of of your flight simulator.
Shah, is it possible
Yeah.
that the pilot's aircraft is actually not in tune with the most of the other aircraft? When they say, for example, feeling rudder tu dah lain.
Okay.
Sedangkan
Yep.
yang sebenarnya lah kapal terbang dia yang yang mungkin ketat sebab Boeing dia ada actual mechanical linkage. Dia
Betul.
ada actual mechanical linkage and also
But
supported by hydraulics.
yep.
Sedangkan simulator kalau macam Airbus tak adalah, dia fly by wire, so dia feeling dia tak ada
Yes.
sangat. Tapi
Yes.
Boeing yoke dengan rudder pedal ni dia ada feeling. Dia ada feeling
Yes.
dan boleh jadi antara kapal terbang dengan kapal terbang feeling ni pun tak sama. So pilot
Betul.
A mungkin dia kata yang ini terlampau ringan contoh.
Yep.
Pilot B kata okey je. Pilot C
But
kata berat sangat.
yes. But when it comes to in the aviation world, usually we use aircraft as reference. Okay.
Okey.
Because of how good because the thing is it goes back to the aircraft maintenance. So basically based on the AMM aircraft maintenance manual, we do have like a document saying that how much stock you need to put in, how much what's the gauge for the cables, right?
Okey.
So it has to be precise. So that's why we usually neglect that part and we assume the aircraft is always perfect for now.
I see.
right?
Oh, in the case of
Until something
Airbus,
happen.
kalau in case of Airbus macam mana? Because it's stick, dia tak ada feeling kan?
Yes, tak ada. But this is the okay. What happened is, so in order when all our flight simulator for Airbuses, right? We use the exact aircraft, whatever the stick that we use aircraft, we put it on the simulator. So that one becomes a, a real aircraft parts.
I see. Alright.
So if that one fails, then we can't just simply modify it. We can't. So we need to go back to the manufacturer and get a new one from them.
I see. Okay.
Uh, okay, Prof.
Okay, proceed.
Okay. So now another sample. This is mostly I'm trying to give you a sample cases most of the time. So now is the Fugit dynamics. So this actually when it comes to Fugit dynamics, what we are testing, we are testing the oscillation of the aircraft, right? So this again, there's in the aircraft manufacturer data, give the integrated data, it will show you how the aircraft should behave objectively, right? So again, so if you see the blue, okay, this one is it comes from a different manufacturer, all right? So the reference, what I mean manufacturer is the simulator manufacturer. So every simulator manufacturer will have their own way of representing their documents, the QTGs, but as long as they follow the guideline, it doesn't matter how it works, how they represent it. As long as the information is complete, the authority will be happy, right? So this is how one of the FTD. So if you look at the reference data for the Boeing 777-800 winglet with with 27K rated engine, so when you push the rudder up and down, so the oscillation, the calibrated airspeed, the pressure attitude, rate of climb should match the aircraft, right? So and also there is a tolerance being given by the authority in the PRD, how much it should differ, right? As long as within the tolerance, they're happy. But if it's not, we have to rectify why, right?
Okay.
So that's the job. Sorry,
Alright.
yes,
Sorry,
Prof.
sorry ganggu. To my students yang
Mm,
flight performance ni, Fugit ni diajar dalam course yang satu lagi flight dynamics. Fugit is basically an interchange between kinetic and potential energy. Bila mana aircraft in steady and level flight, and then suddenly diganggu lah, kata-kata gerak sikit stick dia tu. So it will initiate an oscillation yang mana uh, dia akan maybe climb a little ataupun akan dive a little. So masa dia climb, dia akan hilang speed, less lift, and then kemudian dia akan turun. Dia turun, dia increase the speed. Okay, and also increase dia punya kinetic energy. So bila dia dapat more lift, dia akan climb balik. Tapi lama-lama dia akan hilang lah. It will take about few minutes lah untuk hilangkan benda Fugit ni. So this is what happened lah. Apa kalau kita this is one way lah, macam Cik Syah kata tadi, one way to test apa the model kan, the dynamic model of the simulator. So kita comparekan dengan the actual Fugit dynamics of the actual airplane. Okay Syah, continue.
yep.
Cik
So
Ali, Mukris ada angkat tangan.
yeah, Mukris.
I wanted to ask, because you mentioned the Foucault dynamics, right? So
Mm-hmm.
you and I both know that this one is based on the aircraft's ability to kind of stabilize itself over a period of time, kan? So
Correct.
masa you test benda tu kan in the flight
Mm-hmm.
simulator,
Mm-hmm.
do you guys give like pilots a flying profile, or do they already know what kind of things to do with the aircraft so that they can get this kind of like data set, and then you can compare it with the sample cases that you get from the QT?
Okay. So what happened is, like I said earlier, the uh, the aircraft manufacturer engineers, they developed a script to run this one. So basically, there's no pilot needed. The system will do everything for you. What need to whether the yoke need to be pushed need to be pushed or need to be pulled at how many degrees, and then what's the how many pounds need to be pushed and all that will be calculated by the script. Right? You just push a button, the script will run everything for you, right? And at the end of the day, it will the requirement for Fugoid, for example, is 300 millisecond. That's the requirement for the 300 seconds, sorry, for the whole testing, right? So you can't expect to wait until it stabilize or reach its equilibrium. You can't wait for that. So, but because in order for depending, the bigger the aircraft is, the longer it takes. But for authority requirements is 300 milliseconds. That's the minimum requirement. So as long as the path, the oscillation follows the aircraft manufacturer, the what's being written by the aircraft manufacturer data, they are happy with it.
I think to put it in a simpler language that this undergraduate student can understand,
Okay.
yeah, it's initial ataupun initial condition of the airplane must be established, nombor satu,
Yep.
and then
Yep.
kemudiannya kita masukkan input. Okay, for example 1 degree elevator input ataupun that represent maybe
Yep.
berapa degree stick punya input dengan berapa
Yep.
pound of force. So that is the input punya position, and then lepas tu kita akan
Mm.
biarkan dia respond macam mana. So dalam kes ni kalau kita tengok gambar Fugai ni, dia bagi apa input tu. Kita boleh bagi step input, sama ada step input ataupun
Yep.
kita boleh bagi impulse input. So nampak dalam
Yep.
gambar ni macam impulse input, tapi kalau kita bagi step input, kita boleh measure dia punya overshoot, dan
Mm.
kemudiannya macam mana dia akan apa, by measuring the overshoot, then we
Yep.
can calculate dia punya damping ratio,
Yep.
damping ratio, and boleh calculate dia punya natural frequency, and also the undamped natural frequency. And
Mm.
kemudian kalau dari segi flight apa aircraft engineer ni, bila dia nak design kapal terbang, itu yang dia nak kena lepas berdasarkan the standard. Untuk civilian, civil aviation, dia mungkin tak pakai standard yang macam military lah, dia ada standard lain. Tapi untuk case flight simulator, I believe you mesti compare dengan yang actual airplane lah kan, daripada simulator.
Betul.
Kan, so you ensure that the simulator betul-betul represent the flying dynamics of the actual aircraft.
Yep.
Okay, alright, we'll continue.
Yeah, just to add to Mukri's question and also what Prof Rizal cakap tadi. So basically the aircraft data tu, it was tested on the real aircraft. Okay, like for example Fugoid, they really test the Fugoid on air with 737-800, but this one is only being done once. Okay, the thing is, if you do a Fugoid on real aircraft, if a pilot is doing it manually, the result going to be different. It's going to differ from one result to another. So that's again, it's very subjective, right? So but usually for the 7.3, I give you an overview how it's being tested. So what they need to do is you need to establish the initial condition, which is what the wind going to be, what is going to be like the what do you call that, the altitude, what's the speed going to be. Okay, so what happened is, in the aircraft, if you do it manually, which I've done it a million of times basically. So what you need to do is the yoke, for example 7.3, you pull it up, you pull it, and then the moment the nose pitch, right, and then when the nose pitch, your speed going to decrease. The when the speed decrease by 5 knots, you let go. You let go the yoke, and then you start seeing the aircraft pitching, oscillating up and down until it stabilize. But in order for 7G to stabilize, it takes a long time. But for the system itself, what our requirement is only 300 milliseconds, 300 seconds basically. Okay, are you okay, Chris?
Yes, sir.
Okay. All right. This is the flight controls. So tadi we are talking about, I think this one is this is more on the yoke itself. So we are also testing this. How good is the performance of the aircraft yoke? Whether the force is well calibrated on that one. So just this QTGs just to make sure that the flight control field and rig like the real aircraft. That's why I said when the crew complained earlier, for example, like the rudder. So we run all these cases first for rudder. We want to have the objective to pass first. Kalau if the objective also fail, there's no point of getting another pilot to test. Fail is a fail. Okay, so we will be testing each flight controls of the aircraft, of the flight simulator, and measure the force and position and reaction time for release. And basically, like I said, poor calibration of the mechanical can affect other flight QTG as well. So might as well you get this one done, and then the rest gonna be okay, inshallah. Okay, this is very super important. Okay, so transport delay. What is the transport delay? So basically, the purpose of transport delay is to move the flight control and measure how long it takes for everything else to respond, such as instruments, motion, and visual. Okay, there's four main character that we need to test. Starts from the control, the instrument, motion, and visual. Okay, the main reason for this test is uh, the reaction must be less than 150 milliseconds. The moment you put, let's say for the, when you pull the yoke, for example, until the end of the process, it should be less than 150 milliseconds. Or else, I've seen a crew get sick because the disorientation. I've seen it. They vomit in the aircraft, that's normal. Okay. So when they feel sick, we know that something's not right. So to give you a better explanation, uh, the if the leg is too long, for example, okay, there's an input. The pilot put the input in. Okay, the motion or I think is the visual must go first, then the motion. Okay, the the difference between the motion and visual, if it's more than 100 milliseconds, the crew gonna vomit definitely. Because of what? What happened is the visual. Let's say they bang to the left or right, for example, it bang, right? But what they see, in front of them, the aircraft is banking, but the field stays, right? So that what makes them feel disorientated basically. So there's a lag, too much lag. So as long as between less than 150 milliseconds, they're gonna be fine. So this is very crucial. But except for like FTD, this 150 millisecond only applies to level C and level D flight simulator. For lower flight simulator like the FTD, for example, I think you need to, the minimum is about 300 milliseconds, because there's, like I said earlier, it's less credit towards the training.
Shah,
No,
this delay is not caused by the dynamics of the airplane, but it's
no,
basically
no. It's
it's
just
a
the feel.
computation delay lah kan.
Yes, correct. It's a
Komputer lah,
computation delay.
maknanya kalau
Yeah.
ada delay tu panjang sangat boleh jadi
Uh,
uh, memory tak cukup ke apa.
yes. It depends because, okay,
Processing
the problem is,
lambat tu.
okay, so it's going to be it's going to be a complete loop. Okay, how the simulator works is, okay, from the input, from the captain pilot input, it goes to, okay, there's two sections. One is the mechanical section and also the computer section. Okay, pilot give an input, and then it goes, okay, it's supposed to go to the computer. Okay, the computer will process it, but the computer is binary, is 1 0. They can't read the mechanical input. Kan? So what happened is, we introduce something we call interface system, where it translates from the mechanical into binary, which can be read by the computers, and the computer process it, and it sends back all the data to all other instruments, like the instruments, how the instrument should act, how the visual should act, and how the motion should act. So the whole process it should be less than 150 milliseconds.
Well, that's quite a lot of computation because it,
A lot.
yeah,
So that's
not
why
only sending back
we
to the um, uh, display ataupun
yeah
monitor yang ada kat depan,
Yep.
uh, but juga pada instrumen yang lain kan, primary flight
Yep.
display dia,
Yep.
and and then dia akan translate balik into analog
Betul.
signal kepada apa apa benda bawah tu, kaki yang control the
Motion.
position tu kan.
Motion. Yes.
Uh, itu a lot of competition tu, so
Yes.
buat tahu komputer
So
dia
that
besar mana komputer dia.
so for us we have biasanya for 73 we have about seven server computers. So it's a
Per
server. So
flight
it's
simulator,
per flight meter.
7
Other
computer.
set, but it's not normal computer. It's a server computer which is
So
super fast.
mhm.
Yeah, you are looking at about the clocking speed is super high. Macam it's like a data center. Kan? So you have the whole thing. We call it a server rack. Basically, it has about 7 or 8, and then this every computer or every node we call it controls one system.
Yeah.
So also there's a master computer lah, which control the smaller system ni.
Do they put aircraft computer, aircraft kalau kapal terbang betul dia real aircraft, they
Yep,
have like
yep,
very few computers to control the airplane. Will that
yep.
be included in the server, dia punya control law?
It will be okay. Let me explain about what they call that. But for example, the Maxes. Okay, the most of the aircraft has been quite matured, so they are able to do, we call it rehosting. Rehosting meaning that they program a computer that acts exactly like the aircraft box.
I see.
So that's where it becomes a simulated instrument, which is cheaper. But for the Maxes, is still new, so we still have some sort like a aircraft box on board, a certain computers in order like airing computer. We still need that because it's quite new. The airing that being used by the Max is quite new, so we need that until maybe 5 to 10 years down the road. Maybe they are developing another rehost, then
Un-
the Max gonna
until
be
they can
fully
replicate,
stimulated.
then they can develop a new computer that can
Yes,
replicate the actual
yes,
computer on board lah.
yep.
Alright. Okay.
Yeah.
Proceed.
Okay, so transport delay. Okay, this is basically our processes, all right? Okay, the initial evaluation. So when we first install the machine, first thing first, what I need to do is I need to do ATM, we call it acceptance test manual. So acceptance test manual is something like, okay, is every system has its own ATM. So for example, flight instruments. So if I flip this switch, what should happen on the instrument, for example? So this one is a document that I need to check to make sure that that aircraft is as per simulator. Let's say it says that when you flip the arm switch, it's supposed to come up with a green arm initiator on the PFD, but it come out with white, meaning that it's wrong. So I will go back to the manufacturer, fix it before we start the whole certification process. Once I got everything fixed, okay, in order to do that, your knowledge of aircraft has to be very super good for that particular aircraft, right? Okay, I'm not a pilot. Yes, I can fly, but the thing sometimes as a simulator engineer, I work close with the SMEs or the pilots to make sure that we have everything the IC is correct. So I always get one pilot to check the ATM with me to make sure everything's good. Okay, once I'm happy with the ATM, then we start the certification process. We start scheduling when the inspector from EASA or UKCA or even our CAA Malaysia to come in. Okay, uh, so the SIM manufacturer will do the first review. They run the first case of QTGs. It's about 450 cases in total. They produce it. It's about 4,500 pages, and the SIM operator will review it. So the SIM operator will let the SIM manufacturer know whether they're happy or not with the flight simulator. If it's not, the SIM manufacturer have to tweak or they have to modify whatever they do in order to make the sim operator happy. So usually in, for example, in Ryanair, I was responsible for as part of the sim operator. So I evaluated all the sims, I evaluated all the QTGs. I flew all the sims, making sure that it feels good. Uh, because the thing is, yes, people say you are not a pilot. You, how do you know it's correct? Because uh, I've been in a perfect sim before, so I know how it feels. After 20 years, basically, you have the senses knowing that the how good is the aircraft, or if something is sluggish, you'll know. Once the sim operator review, once I'm happy, the authority will comes in to review it. If they're happy, and then that document they're gonna stamp it, and it will become the master QG, will be the reference for the next 10 or 20 years, right? This document can't be destroyed because it has to follow the sim everywhere it goes. For example, I dismantled one sim from Amsterdam. I was there for 3 months. I dismantled 77 800 winglet. Uh, so whatever they produced in Amsterdam 10 years ago, I have to bring back the whole document to Malaysia as a reference. Because when we rebuild the flight simulator, reinstall the flight simulator in Malaysia, when we test it, the result should match the master. If it doesn't, something went wrong along the way. So that's something that we don't want. So we always do a baseline, making sure that the performance is at par. So again, QTG is always our main reference. So now we are going to the recurrent evaluation. This is the yearly event, right? So you run every year. We run all the 145 cases. Uh, we compile it. We get the authority to review it. So if they're happy, then we get another year of certification. Without the certification, the crew can't train. Like, let's say if a crew train on a uncertified flight simulator, basically their training become null, and it become invalid. The training become invalid in general. Okay. Okay. This is something very interesting. There's a story I want to share. So if you guys remember, the 737 Max was grounded for almost 2 years because of Lion Air and Ethiopian Airline. I think Dr. Rizal must remember we had quite a discussion on the Lion Air.
I was
You can-
interviewed by Bernama because of
Ah,
this, and I said there's something with the program at the tail side.
yes.
Then we had a discussion, long discussion. Actually,
Yeah.
the I wasn't expect. I wasn't expect. I didn't expect the interview. I
Mm,
just I just watched the program.
yep.
I the audience, yeah. I watch the program from
Ah.
home, and suddenly the
Mm,
television called me and asked me to respond to it. Okay. Luckily we had discussion before, so I
yes.
memang dah suspect benda tu, and it was actually part
Mm.
apa nama program dia tu, apa nama sistem dia tu, lupa lah sistem yang fail tu.
MCAS. MCAS.
MCAS kan, MCAS. MCAS was
MCAS. Yep.
actually was quite similar to my PhD thesis dulu, SAS dia panggil,
Yep.
Stability
Mm,
Augmentation
mm,
System. So
yep.
nasib baik I boleh terangkan benda tu. Otherwise
Ah.
dia orang tanya I blur lah. Okay,
I
Syah,
think a
sambung.
night. I think a night before that, I think we did sit down in Kuala Lumpur, just
Yes.
discuss about this. Okay. So okay, just to continue what we are talking about. So the Lion Air. So because of these two issues, all the 77 Max in the world was grounded for almost 2 years. So there's no way that until they rectify the issue of the MCAS, um, there's the authority worldwide, FAA, EASA, UKCA won't allow the Max to fly over their airspace. So Ryanair bought a lot of Max. Okay, so now the so based on, okay, CAE developed a 737 Max simulator with something we call it BSP, a special computer, we call it BSP, Boeing Simulated Processor. Okay, so this box is only being controlled by Boeing. It's only meant for what do you call that, Max flight simulator. So 2 years, we've been given, okay, when the aircraft, okay, we have something we call it validation data roadmap, VDR. Okay, there's the process of how you're being certified at some point. But when when the aircraft crash, it was under VDRC, if I'm not mistaken. So it evolved. Then I came to Ryanair. So it became my responsibility to make sure this is at par. So I work close with CAE. Boeing give the so Boeing make rectification based on these two issues. They did a programming on their aircraft to make the MCAS works properly. They did investigation after investigation. So they gave us the first VDR level, VDRD Delta. So, but somehow it performs, but it doesn't work well. It doesn't work well. So I'm not happy with the QTGs. They presented me with the QTGs. I'm not happy with it. I run the QTGs. I'm not happy with it. So if not only the aircraft, the simulator is also grounded for 2 years. So and then so what happened next? The first year we got VDRD and we got VDRE. Okay, starting from VDRE, there's a lot of improvement by Boeing. Okay, uh, the what do you call that? The QTG start improving, and then in order for the MCAS to work, they put uh, extra things on the PFD to make sure to counter the MCAS issue. So me and the SME from Boeing Seattle, our own SME in Ryanair, and also myself, we evaluated the same. They evaluated I evaluated the same on the objective side, they on the subjective side. Okay, until the end of 2021, right? So now Ryanair is pushing, because they bought a lot of aircraft, they can't afford to have the aircraft grounded for too long. They push the authority to approve the Max to fly. They push FAA as well. So what happened was UKCAA now, okay, it seems that the system stabilized, the aircraft seems stabilized. They're happy with the report from Boeing. They're happy with the investigation, and they're happy with the rectification done by Boeing. So it's time to test. So now Max can't fly over the UK airspace. There's no way. So the next best thing is to test the software, the fixed software on a flight simulator. Okay, Boeing gives CAE the software, and CAE gave us the software. So I install it on the flight simulator, and I ran the full suite of QTGs, 145 cases in total, right? So now the end goal is for us, for the aircraft to fly in the UK airspace. So it took me, okay, I was given the responsibility to check the system performance, to check the MCAS, and also to check the objective side of it. So we have Ryanair, pilots from Ryanair, we have pilot from Boeing Seattle, and I have myself. So first phase is to check the objective. So I did check every single pages, 4,500 pages check. It took me about 2 days to check all the graph performance to make sure that everything's good. Um, I checked everything. I tested everything. Everything seems to be as they call it here, as advertised, as how it should be fixed. I see all the bell and whistle that they put into the system. It seems to be working fine as per their ATM and all that. So once I'm happy, I had to sign off the document. the document on the QTG saying that I'm happy with it. So I approve that all the aircraft performance that is is performing as how it should be. Okay, so now because the thing is UKCAA is using Ryanair as a test platform. So just imagine signing a document which is uh, will make the aircraft fly at some point. That's the first stage. I sign it off. They're happy with it. I can, and then the next phase is the testing part. So the testing part is we have again Ryanair, Boeing SME from Seattle, and also UKCAA inside the same to test it almost 8 hours a day for 3 days to make sure all the bell and whistle that Boeing advertised was working as per uh, how it should be. So because if I say I'm not happy with the document, the QTGs, they're not going to proceed with the second phase. So because I'm happy, I sign it. They check it. Okay, now is the subjective testing part. Then after 3 days, they're happy with it. They're happy with it. So Ryanair and also our SME, and then also the Boeing SME from Seattle send a report to UKCA that they're happy. Everything seems to be legit. So my QTG has been sent. Everything's happy. So what happened was after the initial testing, 2 weeks after that, we received a UK CA UK release. I think it's a. I don't think it's a press conference, but the thing is, they did approve that from now is I think in December 2021 that the Max can start flying on UK airspace because of what we did in Ryanair. So that's why flights. How important is flight simulator? How important is the performance, the QTGs? Because this is what defines the flight simulator in general. So I've seen a lot of changes. I snapped a bunch of pictures. I can show you at some point how the MCAS looks like, how on the PFD if the MCAS fail, because now Boeing said all the max pilot must have a special training, additional training uh, on MCAS fail issue. So they added a malfunction. You press the malfunction, the MCAS will fail, and Boeing came up a procedure on how to react to the malfunction if the MCAS fail again. So this is, and they put a lot of backup in the system saying that if the MCAS fail, what else can they rely on? So that's the whole story. How uh, how the Max came. It's quite a panicky punya situation juga at that time because I signed a quite an important document, and then when it comes to the uh, because the first I've been monitoring all the Maxes flying in case anything else happen because your name is on the line basically. Uh, so Alhamdulillah until now it has been about 2 years already. Everything seems to be fine. So we are off. All of us are off the hook. So we can attest that the flight simulator and the aircraft is as how it should be, how it should behave. And I can say the MCAS is totally fixed by Boeing. They did quite a good job. But yeah, when it comes to business, they lost a lot of customers. They receive a lot of cancel order. Uh, but I think they are getting back on track on that one. Right. So I think that's the end of my presentation. I hope it's a beneficial one for you on the industry perspective. But again, if I got my email that if you feel like you have any questions or you want to speak to me personally, feel free to email me. I'll see how I can help.
All right. We have a question from Atika.
Uh,
QTG rerun is only done once a year, is it?
yes.
Or there are a few rerun in it, so only once a year.
Okay, basically it's only once a year, every year. So every year we have to every year we have to present the same document.
I see.
Yeah, so 145 cases, we have to run it. We have to represent, because the thing is, there's one way of looking at if the sim is degrading in term performance. If you start saying that, okay, sometimes it doesn't fail, but you can see that the it start deviating from the master. Okay, let's say initially it was on the dot, suddenly when you run next year it become like the graphs, the plot start to deviate from the master. It's showing that something is degrading. There's a system
Yes.
degrading, so you need to rectify. So I think when it comes to QTGs, it will show you which part that causing the that particular performance. Usually we are not worried too much on the flight controls plot. What we are worried is about heading, the outcome of it, the heading, the calibrated airspeed, the ground speed. So if this, that is why all this in FCS FSTDA, when it comes, they will tell you what you need to look at, right? For example, normal takeoff, you'll be looking at calibrated airspeed.
Yep.
If you have the calibrated airspeed, they give you a tolerance, usually about plus and minus 3 knots.
All right.
If it's less, or if it's out of tolerance, which means that something in along the system causing that calibrated speed to fail.
I see. All right. Okay. Thank you for the response. So,
Yeah.
we have here, other than students, we also have Professor Madia, Dr. Aman here, also Dr. Siti Mariam, Dr. Hafiz, Dr. Firdaus, and the rest of the. Okay. Question from Dr. Mariam: how do you ensure realism in the simulator to ensure hilang pula tadi, to ensure an effective training?
Okay, I do ensure realism. Okay. Okay, first thing first, again, we okay, QTG is the, okay, there's again, like I say, there's two ways of looking at it. One is the objective side and one is the subjective side. Okay, and all the sims are being evaluated based on these two main domains. Okay, the objective side is again is on the QTG side, which shows the performance. uh, Once the performance is good to go, and then it goes to the subjective side. Okay, the subjective side is not everyone can do the testing on the subjective side. Only a rated pilot and who's been in line, and there must be a captain with more than, I think, how many thousand hours of flying, and then they are used to that. They are rated on that particular aircraft. So I can't get someone from rated with A320 to test Boeing 77 NG performance. There's no way they know whether it's a good match or not.
So it
So
must
what?
be that particular pilot from that particular
Yes,
aircraft,
yes,
from the
yeah,
particular model, exactly,
yes,
with
yeah,
long experience, and
yes,
I think good sense.
yeah, and then
Because this is a
and then
feeling of butt kan, betul tak?
yeah, betul.
Feeling of butt.
And then in Ryanair, we only have seven. Okay, how many thousands pilots in Ryanair for 77-800? Only seven are
I see.
selected to become the core. So meaning that if any other crews saying that, oh, I don't feel right. Okay, one again, I check the objective. Okay, if the objective is okay, I'll always arrange a time with the standard pilot, which is one of the seven, to test it for me. But most of the time, they will say that it works fine.
Why
Because
why
yang complaints,
why seven? Why not
they are the
nine
chosen one.
or
They are
five?
chosen one. Of course, Ryanair wants to make more, but the thing is, this is these seven are the most qualified at the moment.
I see. All right.
So they can't just simply take any pilot to become the SSB standard pilot. This is only the seven-person who can test the simulator, who knows the aircraft in and out very very well. So
Seven person ni mesti from various background ke apa, meaning ataupun range of umur
it
ataupun
doesn't it, there's no, it's
doesn't
not
matter
age,
ke?
because the thing is, when it comes to flight hours, It's usually it comes with the age lah. Kan? So the older you are, the more flight hours you have.
I see.
So most of them has been flying about 20, 25 years.
But
But I think the minimum I met is about 15 years.
if the pilot is about 60 years old, then maybe they're becoming less sensitive to
Yes.
banding dengan orang yang lebih muda kan. So
Betul.
it's hard to find a very experienced pilot at the age 40 mungkin. Less than 40
And then
susah lah.
for all these SSPs, the standard pilot, if you ask their question, they will have the answer
I see.
for you. And then, for example, there's because okay, again, we are not pilots. We don't know the system in and out very well. So sometimes there's a crew said, oh, there's a representation on the PFD which can be changed on with a switch in the cockpit, which something that we don't know is hidden switch.
Yeah.
So the crew said we reloaded the simulator, we booted out all the PC, it remains the same. So we said it's something physical.
By the way,
So we said
PFD is primary flight display. It's
let me say
basically
yes.
instrumen display yang utama dalam kapal terbang.
Yep.
Serupa macam kita punya
Meter
speedo
cluster.
meter cluster kat depan kereta tu.
uh, uh,
Yang itu dia, in case you wonder PFD benda apa kan. So dia meter depan tu, and then dia is also supported by other displays,
yep.
multifunction display yang lain. So it's basically a computer screen lah. Okay,
Yep.
TFT, LED ke LCD ke. So yang screen yang lain-lain tu is like normal car nowadays. You have IHU, integrated head unit.
Yep.
So itu dia lah, itu nak control function lain. For example,
Yep.
kalau dalam kereta nak main music, nak tengok YouTube,
Yep.
itulah dia. So simulator kalau terbang, PFD tu mesti betul-betul tepat and represent instrumen yang sebenar dalam kapal terbang, dan juga kena tally dengan the environment outside.
Yep.
Yes. Yeah. Okay. Alright. Any other questions? Siapa yang nak tanya secara verbal ke?
Yep.
And especially student.
Apa sah rasa macam kena Viva.
Siap. Soon. Any other question? Alamak, Dr. Mariam dah left. Alright. So kalau tak ada, I stop recording.